hybridization. In haloalkane, this is sp3 and this is sp2 carbon. So this is more electronegative. So due to more electronegativity, the bond will be basically polar. That's why it is less reactive, it is more reactive. And the next is instability of phenyl cation. Positive charge on double bond is very less stable. That's why. Then we started replacement of hydroxyl group. So if you are going to react this chlorobenzene haloarenes with NaOH, or you are going to replace this Cl of chlorobenzene with OH, we will have an extreme condition, like the temperature should be very, very high, 623 Kelvin, and the pressure should be also very high in the presence of H plus. Then we can get we can replace Cl by OH. Now, if in order to increase the reactivity of haloarenes, we need to add NO2. NO2 is electron withdrawing group. So when it will withdraw some electron from the benzene ring, it will be reactive. It will be somehow less stable, not less stable. That's why the condition will be changed. You can see it, the temperature decreases from 623 to 443. Now, if you are going to add 2NO2, that means both the groups will withdraw electron from the benzene ring and it will be more reactive. So the condition will also be lesser. And then if we have 3NO2 group in chlorobenzene, then only warm water can replace Cl with OH. And we did some questions also. Now we are going to start basically the second type of reaction, that is electrophilic substitution reaction. Electrophilic substitution. So see how this electrophilic substitution reaction will take place. So in the first, we are going to read this. The reaction name is halogenation. Can you tell me what does this halogenation means? If I'm telling you hydrogenation, what does it mean? And if I'm telling you halogenation, what does it mean?
So halogenation means when it's attached to a halogen.
No, not like this. See, halogenation, that means addition of hydrogenation, addition of hydrogen will take place. If there is dehydrogenation, that means removal of hydrogen will take place. Dehalogenation, whenever there is a term D before any SN, that will be removal. Like if we have hydration, that means addition of water, and if we have dehydration, that means a removal of water. Are you getting my point?
Okay, sir.
So if I'm telling you chlorination, can you tell me what does it mean?
So addition of chlorine.
Chlorine. This is so simple. So we are going to react haloarene. So I'm going to take chlorobenzene. This is haloarene. And in order to do halogenation, that means basically we are going to add halogen to this, or chlorination. Cl2 will be added in the presence of anhydride AlCl3. AlCl3. So this Cl2, one of the Cl will go and attach at ortho position with respect to this chlorine, and the second product will be basically with this with respect to this chlorine, the second chlorine will go, basically the first chlorine will go at para. Are you getting my point? What I want to tell you is that halogenation, I'm going to teach you the reaction of halogenation. That means we need to add halogen to this haloarenes. So in order to add any halogen to any haloarenes, we have to add halogen in the presence of anhydride AlCl3, And in this way, this chlorine can go at three places. One of the place will be this. This was the same. Three places. I'm telling you, three places. So three compound I'm going to draw. So this is chlorine. With respect to this chlorine, chlorine can be added here, chlorine can be added here, and chlorine can be added here. Okay, so you can see this and this are both same. With respect to this chlorine is at ortho, and with respect to this chlorine is at ortho. That means these both are same, identical. Yes or no?
Yes, sir.
Now, the next product I have written is that with respect to this chlorine, this one chlorine will be added at para position. So the first question comes in your mind is that with respect to this chlorine, why chlorine didn't add itself at this place and this place, which is called meta? Do you know what is ortho, meta, para? Are you aware of that?
The positions of which the bond
Yes,
attaches
yes.
itself.
Basically, we have to take a reference. So with respect to this position, this is ortho, this is meta, this is para. In the same way, if you are going to count from left hand side, this is ortho. With respect to this, this is meta and this is para. Are you getting my point?
Yes, sir.
So what ortho and para. Chlorine didn't add at meta. Do you know why?
No, sir. What?
See, before that, I'm going to write. Before explaining that, I'm going to write this reaction again because it's hodgepodge there. And I will ask you a question, then I'll explain why chlorine didn't add at that. So this will be reacting with Cl2 in the presence of anhydride Cl3. So one of the chlorine will go to this position and one of the chlorine will go to this is ortho and this is para. Can you tell me which one of this is major and which one of this is minor? So it will have a name 1,2 dichlorobenzene. Are you taking 1,2 dichlorobenzene? And this is 1,4 dichlorobenzene. So do you have any idea which one of the following is, which one of this of two is major or minor?
Sir, 1,2 dichlorobenzene is major.
That's wrong answer. You know, how you decided that the first one is major?
I just guess, sir.
You just guess. So your guess is wrong. So you can see this is chlorine is here and chlorine is there and they are nearby. And you know that one chlorine has 3 lone pairs, so there will be repulsion between them. And that's why this is unstable. That's why it is minor. Are you getting my point?
Okay, sir.
Generally at ortho position, it is minor. And this is in opposite direction. There is no repulsion between chlorine. That's why it is major. It is more stable. Is that clear?
Yes, sir.
Now see, did you do that resonance of chlorobenzene, if you remember?
Yes, sir.
So can you see the negative charge, position of negative charge? You can see there is no charge in this. Just reply
Yes,
me.
sir. Yes.
Can you tell me, is there any charge in this compound?
Yes, sir.
What
There's
is the
negative
position of charge with respect to this chlorine?
Sir, ortho.
Ortho. Can you tell me the charge with respect to this chlorine?
Para.
Can you tell me the charge with
Ortho.
respect to ortho? So if we are studying electrophilic substitution reaction, that means electrophile will attack. So where electrophile will attack? The position where electron rich species present Electrophilic substitution reaction, that means basically electrophile will attack. Yes or no, Ayman?
Yes, sir.
So what does electrophile means? Any one of you? What does this electrophile means?
So, electron loving.
Electron loving, that means electron deficient compound. The person or the electron, sorry, the compound which does not have electron will love electron, because if it will gain electron, it will stabilize itself. So the compound which is electron deficient is called electrophile. That is electron loving. Are you getting my point?
Yes, sir.
So what I want to tell you is that where does this E plus will attack? Where it will attack? It will attack this position or this position, Cl plus or negative. What do you think?
So it will attack on Cl minus.
Cl minus?
Sorry,
Where
sir,
is
plus,
Cl?
yes.
Cl plus. Do you have any idea of the nature? Like charges repel each other.
Yes, sir.
Unlike charges
They attract.
attract each other. You can apply this method here. There is positive charge, there is negative charge, and negative charge, that means there is two electrons. That means basically electron rich species. So this E plus will attack here, yes or no? It won't attack here. Are you getting my point?
Yes, sir.
In this position, where will it attack? It will attack here because it is electron rich species, or it is the position where electron rich species is present.
Yes.
So can you see any negative charge at meta position in this resonance?
No, sir.
So that's why meta is not possible here. Are you getting my point?
Yes, sir.
We are studying electrophilic substitution reaction. That means E plus electrophile, electron deficient compound will attack to the position where electron rich species are present. So during resonance, you just saw that the negative charge, that means electron rich carbon, is at ortho and para only, not on meta. That's why the product of at meta is not possible. Okay, I think you got it right.
Yes, sir. I got it.
Okay, please write it. Madhi, we just started electrophilic substitution reaction of haloarenes. So in this, we just started halogenation. And what does halogenation mean? Addition of halogen. So in order to add halogen to a haloarene, that we take chlorobenzene, we will do it in the presence of anhydride AlCl3, which will help to make it electrophile. You will see electrophile. And that electrophile will attack at ortho and form this, and para like this. So the major product will be para, because there is no repulsion between chlorine, and the minor product will be this, because there will be repulsion between these two. So it is less stable. So that's why it is minor and this is major. Please let me know when you are done with this. Let me know when you are done with this. The reactions are very easy. Did we have any test in the last week?
No, sir. We didn't have.
Madhya, am I audible to you? Nowadays, you are not responding at all.
Yes, sir, you are.
About this.
So your voice was breaking. Can you say again?
I was telling you that if you have any doubt in this, please let me know.
Okay, sir.
Okay, one more thing is that I wanted to ask about the syllabus of your upcoming exams, and I'm making short notes for all of you. You will get it before your exams.
Sir, my school has cancelled all exams for me.
That means you are going to have final exams, annual exams.
Sir, can you repeat because your voice is lagging?
My voice is lagging. I was saying that that means you are going to give directly the annual exams.
Sir, they instead of having half-yearly exams, they're doing tests every week on one chapter, and then after that, they plan to complete the whole
There will
syllabus by November
Pre-board.
15th.
pre-board.
Yes, sir. No, sir, not
That's
pre-boards
nice.
now. So after November 15th, they're going to do the pre-boards. But now it's just small tests every week.
Okay. If you have have you given any test?
Yes, sir.
Weekly test?
I have
Okay.
just one test. No,
You just give. What was the syllabus?
just solutions chapter.
Do you have the what we call it, the unit test question paper?
Yes, sir, I do.
Okay. You are added in WhatsApp group, right? In my WhatsApp group.
No, sir, I'm not.
You are not added. Okay. Do you have? Just send the question paper to coaching's WhatsApp number.
Okay, sir.
And tell them to send it.
Okay, sir, I will.
And you will soon be added in your group. Okay, everyone done with this?
Yes,
Sir,
Maria, what
for
about
me,
you?
my midterms are starting from 4th October.
What is the syllabus?
Sir, I have 5 chapters for chemistry this time.
Wait a minute, let me write it. Just write it. Let me. 5 chapters. Okay, let me know the name of the chapter.
Okay, sir. Sir, should I tell you the chapters now or like later?
You can send that to WhatsApp group. I think you are added in that.
Yes, sir, I am there.
Okay. Okay. Have you
Okay.
given any test?
No, sir, we don't have tests right now. We have midterms, and then after that, we have unit tests.
Okay, no problem. So everyone is done with that. This part, halogenation.
Yes, sir.
So now we are going to. Are you done with this, Madhiha?
Yes, sir, I'm done.
Okay. So the next topic is basically nitration. So see, what is nitration? Basically, this is addition of nitro group. Nitro group. So we have a haloarene that is chlorobenzene, and we need to add NO2 group to this. So it will be added at ortho and para only, not at meta. Yes or no? Because I already explained why the product at meta is not possible. Is that clear to everyone?
Yes, sir, clear.
So in order to add meta, we will NO3 in the presence of concentrated H2SO. So NO2 will be added at 2 positions, and the position is fixed for now at ortho and at para. Now let me know which one is major and which one is minor. What do you think? its name is 1-chlorobenzene. Oh, not 1-chlorobenzene, sorry. Its name is 1-chloro-2-nitrobenzene. 1-chloro and 2-nitrobenzene. And its name will be 1-chloro-4-nitrobenzene. Basically, this nitro group is also a substituent and chloro is also a substituent. So we are going to give preference on the basis of alphabet. C will come before N. So let me know the which one is major and which one is minor.
Sir, the second one is major, 1-chloro-4-nitrobenzene.
Yes. This will be major and this is minor. And you also know, both of you, that the product at matter is not possible, right? This is not possible. Please let me know when you are done with this. Done with this.
Yes, sir, done.
Okay. Nadia, you are also done with this.
Yes, sir, I completed.
After this, you have completed, right? Sulfonex.
Yes, sir.
That means, thank you. That means we are going to add sulfonic acid. So in order to do sulfonation, we need to react this haloarene, that means chlorobenzene, with concentrated H2SO4 and heat. So there will be addition of SO3H. This SO3H is known as sulfonic acid. It's a functional group. You have studied about this in class 11. So chlorine will be here and SO3H will be here. And again, chlorine and SO3H. And what will be the name? This SO3H is a functional group. So we are going to give preference to this functional group 1, 2. So the name will be 2-chloro-benzene sulfonic acid. Sulfonic acid. and its name will be 4-chloro benzene sulfonic acid. So you can easily predict which one of them is minor and major. Please do this. Are you done with this?
No, sir, not yet.
Okay.
Done, sir.
Very good. Aman. Aman, are you done with this?
Yes, sir, I will.
Very good. Now see, the next electrophilic substitution reaction, fourth is Friedel-Crafts alkylase. This basically this will be divided into two parts. So this is Friedel-Crafts Friedel Crafts reaction. So there are two types of Friedel Crafts reaction. The first one is Friedel Crafts alkylation. Alkylation, that means we are going to add alkyl group. And how we are going to add? So basically, if there is a chlorobenzene, that means haloarenes. And in order to add alkyl group to this, we need to react this with CH3Cl. That means we are going to add this alkyl part, methyl, in the presence of anhydride AlCl3. So this CH3 will be added at two positions. There will be two products. One is at ortho and the second will be at para. So please let me know the name of the compound as well as which one of them is basically major and minor. And the second part of Friedel Craft reaction is Friedel Craft's acylation. Acylation. Basically, there is a functional group that is known as acyl halide. It is a carbonyl compound C double bond OX. So we are going to add acyl group to this. So how we are going to do this? It will be in the same manner or way. There is a chlorobenzene and we are going to react this with acyl halide. This is CH3COCl, acyl halide. In the presence of same anhydride AlCl3. So there will be addition of acyl group with respect to chlorine. This will be like C double bond O CH3 and again at para with respect to chlorine double bond O CH3. Please let me know which one is major and which one is minor. Let me know when you are done with this. Are you done with this?
Done, sir.
Very good. What about you, Aman? Aman, let me know when you are done with this. Aman, are you there?
Yes, sir. Came back.
Okay. You are done with this?
Yes, sir.
Okay. Now the next chemical properties of haloarenes is basically this is third chemical reaction of haloarenes, and this is basically reaction with metals. Reaction with metals. So the first reaction with metal is known as Wood's fatigue reaction. Wood's fatigue reaction. You know, Wood's reaction we have already done. Wood's reaction, that means alkyl halide react with sodium in the presence of dry ether. And Wood's fatigue reaction, basically it is when alkyl halide and aryl halide, that means arene, haloarene, haloalkane and haloarene react with sodium in the presence of dry ether. So I'm going to write a mixture of an alkyl halide and aryl halide gives an alkyl arene when treated with sodium in dry ether and treated with sodium in dry ether and is called, what it is called, Wood's fatigue reaction, and it's called Wood's fatigue reaction. So basically you can understand with an example. This is our haloarene, or you can say aryl arene, and you are going to react this with sodium and alkyl halide, that means XR. Can I write RX as XR so that you will understand this part will be eliminated and this carbon will be directly connected to this R. So this reaction will take place in the presence of dry ether, and what you will get, this is arene and this is alkyl, so alkyl arene. Got it? If you have any doubt regarding this, you can ask. Let me know when you're done with this.
Yes, we're done.
Maria, are you done with this?
Yes, sir.
Okay. Now the next type of chemical reaction, it is also part of reaction with metal, is fatigue reaction. See, Wood's reaction is about alkyl halide and alkyl halide. Alkyl halide only, haloalkane only. Fatigue reaction is only about aryl halide. So basically, aryl halides also give analogous compound, analogous compounds when treated with sodium in dry ether. Do you know why we use dry ether when we are going to react with sodium and magnesium, in which two aryl groups are joined together. It is called Fittig reaction. Fittig reaction. So it's very easy to understand. Wood's reaction means alkyl halide. Fittig reaction means aryl halide reacting with sodium in presence of dry ether. And Wood's Fittig reaction means alkyl halide and aryl halide reacting with each other in the presence of sodium and dry ether. So there is this, and we are going to take 2 moles of this reacting with 2Na in the presence of dry ether. So what you will get is 2 benzene connected with each other. I'm going to explain it again. Just see, we have 2 moles of this haloarene. So I'm going to write it like this. This is the first haloarene and this is the second haloarene I'm going to write. And what you need to do is just remove this and connect this. Just remove this NaX in the presence of dry ether. So this will be two NaX. And this is known as basically diphenyl. This is right. Let me know when you are done. Are you done with this?
Yes, sir.
What about you, Madhya? Very good. So now I'm going to share a PDF file. This is our weekly test. This is about our weekly test. Okay. Please make a PDF of this with date and name and date, and send it to the WhatsApp, respective WhatsApp group or coaching's WhatsApp. Okay. There are 4 questions. Please do this. And after completing it, you may leave.
Let me know when you are done with this. Ayman and Nadia, how many questions you have done till? Please do respond.
So I just have the 14th.
Okay.